Okay, kids, this is going to be the first in a three-part series. This is topic 2A from Unit 1, and we're going to be covering phase changes, and in this screencast, going to deal specifically with the heating curve of any substance, one of a couple graphs that you will see on this assessment. I'm recording this one here at the school, so we'll cross our fingers that JT doesn't blare at us on the intercom. So let's get started. You should know already most of these terms between the phase changes. So we've got solid and liquid, which you know as freezing and melting, depending on if you're going from a liquid to a solid or a solid to a liquid. And we have boiling and condensation, which is between liquid and a gas returning back to a liquid. And the last two here are the ones that are always forgotten, but they're kind of interesting ones, and that is converting directly between the gas and the solid state without going through the liquid phase. So if you start as a solid and go directly to a gas, that's called sublimation. And if you start as a gas and go directly to a solid, that's called deposition. Students think they've never really seen these, but in fact, deposition happens every time that it frosts because the water vapor in the air goes directly to the solid phase, skips the liquid phase, which is why frost has the sort of, crystalline edges to it and doesn't look like just a solid frozen droplet of water when you see it on your car windows. The heating curve that we're going to be talking about in this video is basically a graph version of this statement though, so I want to spend some time talking about that, which is that anytime one of these phase changes occurs, all the energy that's coming in goes to transitioning between the two states, and none of it goes to changing the temperature. So in other words, what I'm saying is that when ice melts, that ice doesn't warm up past the melting point until all of the ice has melted. Or when water boils, the water isn't going to heat up any further than the boiling point until all of the water has been turned into the gas phase. So the demo that I'll do in class for this, and if you're watching this after the fact, you can think back to it, is boiling water in a paper cup over a flame. And the reason we can do that is the water is never going to get above 100 degrees Celsius, which is not hot enough to burn the cup until it's completely turned into a gas. So having that water there, as long as there's water there, the limit of the water's temperature is going to keep that cup cool enough that it doesn't actually burn. So let's look at what this graph looks like and see how it represents this statement. So here's the graph, and you're going to see this on your test, and this works for any substance. The lines may be sloped a little bit different, and obviously the melting and boiling points are going to be different for every substance, but it's going to have the same 5 parts. You're going to have a line here, which goes up until this flat part, and then it rises again, is flat, and rises again. So let's think about what this is representing. If I take some ice out of my freezer isn't a very good freezer unless it keeps the ice significantly below the melting point. Otherwise, every time I open the door, everything in the freezer would immediately start melting. So I take that ice directly out of the freezer, and it's something significantly below the melting point. Let's say it's 10 degrees Fahrenheit. That ice is not going to begin melting until it warms up to the melting point. So during this portion of the graph here, what we are doing is we have only the solid state, and what we are doing is we are heating a solid. Once that solid has reached the melting point, it can begin transitioning to a liquid. So melting, or if we're going back down the graph, we would say freezing. And if you'll notice here, energy is still going in because my line is moving to the right, which is energy, but it isn't rising any in temperature. So that's what that previous statement said, which is when we're experiencing a phase change, there is no change in temperature. So my graph is flat here, and the temperature doesn't change until all of the solid is converted into a liquid. So this portion of the graph is the melting freezing phase change, and you are going to have both solid and liquid present at this because this is the transition. Once we've left that, we're completely in the liquid portion of the graph, and we can begin heating our liquid up until the boiling point. So this is going to be heating a liquid. And again, the same thing, a flat portion of the graph because you're adding energy in and the line moves to the right, but we're not changing the temperature, so it doesn't move up or down. And depending on which direction we're moving on this graph, going up, we say it's boiling, turning it into a gas, or if we're going down, we say it's condensing it and turning it back into a liquid. So like the melting and freezing, this is the transition state, so we're going to have two states present here, a liquid and a gas. And once we have completely converted our liquid to a gas, then we can start heating up our gas above the boiling point. So this last phase here is just going to be heating a gas or a vapor. So the questions that you'll see on this will ask you about these 5 segments of the graph here. I'll sort of delineate them there to there, here to here, from here to the end of that, and this section and this section. So it'll be asking you what state is present here, only a solid, what's happening, you're heating a solid, what states are present here, that's the transition, so you got solid to liquid. What is happening here, you're heating a liquid, the only state present is the liquid. What's happening here, you're boiling or condensing and you have the 2 states present. And lastly, what's going on along this section, you're heating a gas and the only thing present is a gas. And of course, the take-home message is that during the phase change, energy keeps coming in, our line moves to the right, but it doesn't go up or down, so the temperature does not increase or decrease. Okay, stay tuned for section 2.